The next example is a typical problem that comes up when we find volumes. It's one way of obtaining a solid is by rotating an existing graph about a particular axis. So for example, find the volume of the solid obtained by rotating about the x-axis, the region under this curve, y equals root x from 0 to 1. So you can imagine if I take this curve and I rotate it around the x-axis, I'm going to get a shape something like this. It's like a bowl. Now, I take a generic slice here at a distance of x. Now, I need to find the radius of this slice. Now, this radius, right, this radius equals root x. Because if you think about it, it's just this value, right? This is getting rotated, right? That's what is happening here. Because the height at each point is the y value, which is root x. So my volume is ax, which is pi r squared. That's area of the circle dx as x goes from 0 to 1, or pi x 0 to 1 dx, which is pi over 2 x squared 0 to 1. So the area is pi over 2. Now sometimes you may have to do the rotation around the y-axis, or you're asked that the rotation is around y-axis and you just have to be careful. So let's look at this example. Find the volume of the solid obtained by rotating the region bounded by y equals x cubed, that's right here, y equals 8, that's right here, x equals 0, about the y-axis. So again, we get a bowl kind of shape, and that's going to be my generic shape, and this radius is going to be the x value, right, which is cube root of y. And in this case, these are going to vary from top to bottom, which means they vary from y value 0 to y equals 8. So I have pi cube root of y squared, and this time it's dy, because what I'm going to do is I'm going to increment it by dy because I'm on the y direction from 0 to 8. So I have pi 0 to 8 y to the 2/3 dy, which becomes pi y to the 5/3 times 3 over 5, 0 to 8. That's 3 pi over 5, 8 to the 5/3. That's 96 pi over 5. Now, the next kind of examples is solids with holes, which we are going to cover in the next video.